Good morning to all. Now, this is in continuation with the previous session where just we started Fourier transformations. Let us start. Now, in this session, we are going to start problems on Fourier transformations. Now, we are going to start problems on Fourier transformation. Now, just look at these are problems on Fourier transformations. Very good, important problems. Now, just look at how just we are going to move it. Now, just look at, there are two problems which are being repeated in most of the examinations. First one, how they ask is that find Fourier transformation of a signal or a function, that is f of t equal to t when mod t is less than or equal to a, that is equal to 0 when mod t is greater than a. That is the question. 0, that is the mod t is greater than a. That the question, it is one of the repeated questions on Fourier transforms in university examinations. Now, first just look at, this is the given. Now, Fourier transformation of any signal or function, that is equal to integral minus infinity to infinity f of t into e power minus j s t in terms of dt. In terms of dt. This is the first formula of Fourier transformation. Now here, one important thing students have to remember. Whenever a formula is given like this, students have to rewrite the signal. Whenever there is a modulus, you have to rewrite the given signal. How to rewrite? That is f of t equal to t. Here just look at, in intermediate what you did, if mod t equal to a means what? That is mod a is less than or equal to t equal less than or equal to a. There is a meaning of modulus of a variable or a function. Therefore, we are applying the same thing here. So here, that is minus a is less than or equal to t is less than or equal to a. Its value equal to 0. For example, look at mod t is greater than a. Modulus is only for which one? Making negative values into positive values. Now, already greater than a is a positive value. So, no need to use the modulus here. Directly just you can make it t of a. Now, we consider now this signal. Now, we consider this signal only. Got it? Now, just look at it. Now, in this Fourier transformation, what are the limits? Lower limit is minus infinity. Upper limit equal to infinity. In the graph, this is the 0 center point. Now, just look at minus a to a. Minus means for somewhere it is left to the origin. A means plus a, somewhere in the right to the origin. Now just look at, this is the scale of the limits of the integral. Scale of the limits of the integral. Now we have to split the given integral into three parts, because the actually Fourier integral begins with what limit? Minus infinity. But in the problem, the limits are given from minus a to a only. That means what? From minus infinity to minus a, there is no reference of value. Students have to observe very keenly. The limit is minus a to plus a t. Greater than a, 0. After a, the value is 0. But the Fourier transformation limits are not from 0 to infinity. The limits are from minus infinity to infinity. Minus infinity to infinity means what? For example, this is a graph. I am the center point. This is the minus infinity. That is the plus infinity. That means a Fourier transform covers all. What are the possible values? It covers all the values. That is Fourier transformation. That's why the limits are minus infinity, that is infinity. Now just look at, without not having any confusion, students have to make a design of like this. This is the Fourier limits of the Fourier integral from minus infinity to plus infinity. The given limits are minus a means what? This is left side of the origin, plus a means what? This is right side of the origin. You have to make it this one. Now just look at, you have to make all the values because a Fourier transform covers all the values. Now just look at, you have to make it a first integral. You have to make it the first integral from minus infinity to minus a. Now what is the second possible integral? That is minus a to a. Now what is the next one? That is equal to a to infinity. Now just look at the entire minus infinity to infinity total limit of the integral is split into three parts. This is part 1, this is part 2, this is part 3. It is split into three parts. Now just look at. So now we have to make it. What is there in the kernel of the integral? F of t e power minus jst with respect to dt plus you write the same thing f of t into e power minus jst with respect to dt plus f of t e power minus jst with respect to dt. Understanding with respect to dt. Now I am erasing this. I made it for your understanding purpose. Now just look at. Now just look at. Here there is no difference. There is no signal defined under minus infinity to minus a. No signal defined. Therefore, here its value equal to what? 0 plus the actual signal is defined from minus a to a only. So from minus a to a, what is the value of f of t? T. So wherever there is f of t, in that place you are supposed to substitute the value t only. Therefore, this is equal to minus a to a. In place of f of t, there is e power minus j s t dt. Now, next one from a to, from greater than a. Greater than a means what? What is the upper limit of any positive value? Plus infinity. That's why we made it a to infinity. Now for a to infinity, its value, how much? The signal notation? No signal, 0 is given. Therefore, its value equal to 0. Understanding? So now ultimately we are going to get only one signal evaluation is needed. That is e power minus jst into dt. Now just jst. Now this is integral UV model. I already advised you. Understanding? UV model means what? Now I am making the simplification on the right hand side. Now f of t is equal to. Now f of t is equal to integral. First, take t as it is. Now find integration of this value. What is that value? E power minus jst. E power minus jst. That is e power minus jst by constant minus js minus integral e power minus jst by minus js into differentiation of t1 with respect to t. Now between the limits minus a to a. Again I am telling you that don't substitute values once an integral is evaluated. It is always better to keep the values after the final evaluation of the total integral. Now, so this is equal to, look at in the both the cases, what constant we have here. One more point, 1 my js, take the constant. So now what we have, t times e power minus jst between the limits minus a to a. Now, here minus, here just you have taken minus js only out of this one. Another there is minus. Now integrating one more time, you will get minus jst by minus js. Minus js. This minus minus will become plus. Here another difference. This is between minus a to a. No need to make any confusion, students. In the denominator, I am making a parenthesis, minus of js, minus of js. Take this part out of, because it's a constant, it doesn't contain any t variable. Now in this way, t e power minus jst. Now e power minus js, then what will have? Minus of this one, minus of this one. Now again integrating, another minus js will come. That minus, this minus will become plus. Okay, now in complex numbers, what you have? Minus I. Complex number means what? No complex number is allowed in the denominator. So multiply with I in denominator and numerator. I square equal to minus 1. Minus 1 minus 1 become what? I. In electronics electrical we write J. Therefore instead of 1 by minus I, we get what? J. So this will become J by S. Now put uppercase limit A e power minus jsa minus a e power jsa plus, next one, plus take 1 by js as common. This will become e power minus jsa minus e power jsa. Again, no need to have j in the denominator. Multiplying both sides by jj. This will become minus js. So this become js. Now, in the both sides, take a as common. You will get e power minus jsa minus e power jsa. Now, here this will become minus j by s of e power minus jsa minus e power jsa. Now just look at, now simplification, j by s of a times e power I theta, that is equal to cos sa minus j sin sa. Next, minus of cos sa plus j sin sa. Similarly, minus j by s of cos sa minus j sin sa. Now, minus of cos sa plus j sin sa. Now just look at this minus cancels. This is equal to j by s of a times here minus 2j sin sa. Now here again this minus cancels. So you will get only minus 2j sin sa minus 2j sin sa into the constant j by s. Understanding? Expanding e power I theta. Minus of this here minus j, minus of both. This minus cancels, minus 2j. Now here 2j, you can make it cancel. Minus 2j come. Minus 2j into j by s of a sin sa plus j by s of sin sa. Understanding? J square minus, this is 2 by s of a sin sa plus j by s sin sa. Understanding? Sin sa also you can make it this one. So here only just you have to make it a concept. a power minus JSA. This is cos minus of J sin SA minus of cos SA plus J sin SA. These two cancel. Output is minus 2J sin A. But here cos SA minus J sin SA minus of cos SA plus sin SA. Lower limit. Understanding? So this is a simplification of this problem. Understanding? Thank you.